name is Kane, and this is my final year at the web school. And for my senior project, I researched the genetics of strength. So, for my introduction, why I chose this topic. For the longest time, I've been interested in what causes people to have different levels of strength than other people. Why strength is different in certain groups, and is strength actually genetic, or do people work harder than others? So my thesis statement was, strength is indeed genetic due to certain backgrounds and makeup of people's interior muscle design. So for some background information, environmental factors, starting with age. As we grow up and reach our adolescent stages, becoming teenagers, our bodies begin to grow and mature, and we begin to develop more muscle fibers. Therefore, we're developing more strength. And now age, as we reach our senior citizen levels and we become 50, 60, 70 years old, our strength begins to decrease because the number of muscle fibers in our bodies decrease. Now, some illnesses and diseases that I discovered was one, hypotonia, also known as floppy baby syndrome. This is a state of low muscle tone. And then also muscular dystrophy. Muscular dystrophy is a group of genetic diseases that lead to weakness and loss of muscle mass. There are 9 main forms of muscular dystrophy in this world, and I researched 2 of them. The first being Duchenne muscular dystrophy. This is the most common form of muscular dystrophy, dealing with the progressive weakening of voluntary muscles. It's caused by the absence of a muscle protein named dystrophin, which helps keep the muscles intact. So therefore, if this protein is missing, the muscles aren't working properly. The second is Becker muscle dystrophy. This is very similar to Duchenne, however, it's less severe. It deals with muscles becoming weak and damaged due to the loss of muscle tissue, or in other words, atrophy. This is also caused by the absence of dystrophin. So then I researched some genes associated with muscle strength, and I was able to come across 5 of them. The first being myostatin. Myostatin is a growth factor that inhibits muscle growth and regulates the size and number of muscle cells in your body. The second being insulin-like growth factor 1, or IGF-1. This is a protein that influences muscle growth and development and increases dynamic muscle strength. The third being insulin-like growth factor 2, or in other words, IGF-2. This is a growth factor that plays a role in growth regulation of the skeletal muscle. The fourth is alpha-actin 3, capital ACTN-3. This is a protein found in fast-twitching muscle fibers. Now, fast-twitching is important to understand. Fast-twitching has to do with powerful and quick bursts of strength, such as sprinting, bench pressing, squatting, and things like that. And the last one is angiotensin converting enzyme, or in other words, ACE. This is an enzyme involved in vascular function. More specifically, vascular smooth muscle, which is a smooth muscle found in the wall of your blood cells. Here's more background information. As I was analyzing some of my research, I came across this excerpt. G. Bunin and M. Thomas of the American Medical Society of Sports Medicine state, the search for the genetic basis of muscular strength and power is based on 2 approaches, the unmeasured genotype approach and the measured genotype approach. So for the first, the unmeasured genotype approach. Now, before I continue, the word phenotype here is important to understand. The phenotype is the set of observable characteristics of an individual resulting from its interaction of its genotype with the environment. So in other words, your phenotype are your physical characteristics. This approach utilizes information about the distribution of the phenotype among related individuals to estimate genetic parameters. In other words, this approach analyzes the spread of characteristics of an individual to help determine genetic factors. The next is the measured genotype approach, and this approach has two different methods. The first deals with chromosome location. It identifies locations of chromosomes in chromosomal regions that are genetic parts of muscle strength. The second deals with alleles. An allele is any two variants of a gene that have similar position on a chromosome. So the second method deals with allele association. More specifically, a certain allele is examined to determine the natural strength in the muscle. Now, heritability. Heritability is the measure or inheritance of the total traits in a population due to genetic differences. Most athletes, or all athletes, have high heritability due to their genes. Heritability is the main reason genes play a strong role in genetic strength because it estimates 30 to 60% of upper body and lower body strength in all individuals. So, for my primary research, I analyzed a blog by Mr. Beth Squirski. The name of the blog was, How Much Does Genes Really Affect Your Fitness? And from this blog, I extracted three main takeaways. The first being ACTN3, as I mentioned earlier, is the main gene that is associated with muscular power. The second being strength is both of nature and nurture, meaning genes do affect strength, but so do environmental factors such as weight training. And the third takeaway was, based on heritability, strength and muscle mass is about 50 to 60% heritable, meaning genes create 50 to 60% of strength in a human being. For my second part of my primary research, I conducted a Q&A with our own Dr. Broadhead. I posed 4 questions to her, and she provided me, of course, with 4 answers. The first question I posed to her was, is strength genetic and why? Her response being, strength is built by developing muscle. There is some kind of genetic influence. When working out, 2 people can be doing the exact same exercise with the exact same weight, the exact same number of sets, and the same number of reps. However, one person's muscles may look larger and more defined than the others solely based on the interior muscle design and the interior bone design. The second question that I posed to Dr. Broadhead was, how do environmental factors affect strength? Her response being, lifting weights is very strong in this case. The third question I asked her was, do diseases play any role in limiting genetic strength, and if so, what diseases? As she responded with muscular dystrophy, as I mentioned earlier, but she also gave me another disease, which is Down syndrome. And Down syndrome is a sex-linked gene that you're born with that involves an extra chromosome in your body. The fourth and final question that I posed to her was, why does muscle increase/decrease with age? Her response, as we grow, our muscle cells begin to grow larger. The muscle cells are nothing but protein. As we decline in age, our muscle fibers decline as well. So, from my conclusion, I came to this. Strength is genetic. However, genes are not the sole factor in determining muscle mass. Environmental factors and illnesses are also extremely pivotal in understanding/building muscle fibers. Now, I would like to say thank you to my parents for putting me on this earth, Ms. Young for being a great advisor, Ms. Little for keeping all the seniors on top of their research papers, and all of you for listening.